Hello. So this is the step-by-step demonstration of solving and computing for correlation coefficients now using Pearson's R and the other non-parametric measures of correlation. So I have four problems here. So let's try to figure out first what correlation coefficient to use or what technique to use given the problem. So first one is the question here is there a relationship between X rate of poverty measured as percent of population below poverty level and Y, which are rates of teenage pregnancy measured per 1,000 females aged 15 to 17. So this, as you can see, involves both interval level data. So for this one, we will be using Pearson's R to compute for a correlation. Okay. The next problem, a medical sociologist investigated the relationship between severity of illness X and length of stay in hospital Y. Choosing 8 patients at random, she ranked the seriousness of their ailment. So keyword is ranked, and determined the number of days they were hospitalized. Now this one is a problem for or on Spearman's rank order coefficient, no, or Spearman's rho. So why? Because ni-rank ni medical sociologist yung patients according to the seriousness of their ailment. No, somehow it was possible for the medical sociologist to classify people and order them based on the seriousness of their ailment. And because Spearman's rank gagamitin, we also need to rank them based on the number of days they were hospitalized. Now this is interval data, but because the other one has been ranked, no, and in that case, we might not have access, for instance, to their original scores on their severity of illness. What we can do is also rank the other variable y. So even though we know the days, for instance, we can transform this into ranks. Next, a sociologist interested in the relationship between social class. So that's social class can either be nominal, but it can also be ordinal data, no? Because social class, we can sort of rank it, diba? Lower, middle, upper. In amount of reading, ask a sample of 105 children from varying socioeconomic backgrounds about the number of books they had read outside of school during the last year. So for this one, no, because there are just a few social classes. I believe we will be using gamma for this, Goodman's and Kruskal's gamma. No, because I think what they did here is a simple frequency count of those who read books and they were asked about their socioeconomic background. So at least they found out the children's socioeconomic backgrounds. Okay, so let's see. The last one is in the table below are the responses of a sample of male and female students to a question on an attitude scale. Is there a correlation between gender and given response? So as you can see, male and female, so those are two classifications on one variable, and then attitude on a scale. So this seems to be a 2x2 table. So we will be using phi coefficient for this. All right. So let's go to the problems one by one. All right, so we're back. No? So the first one is a problem that will involve Pearson's R. No, the relationship between poverty rate and teenage pregnancy rate. So the researcher the problem has already classified poverty rate as X, while teenage pregnancy rate is Y. No? So This is how a Pearson's R expanded data table will look like. And I provided you this in the email, in the Google Drive and course site. So what we need to find out first is get the sum of x and sum of y. Why? Because that's part of your formula here. That sum of x is sum of y. So what you need to do is simply add all these values together to get sum of x. And you should get 90.5. Now for sum of y, sum together this and you will get 327.7. Now we are correlating, so we need to get xy. So we need a separate column for that. So you simply multiply the value of x and value of y for each subject or for each province in the given problem. And you will get for province A 433.68. So let me check. 10.4 times 41.7, 43.68. And the rest should follow. Okay? Then, just like x and y, their combined scores you need to sum. And you will find 3,836. And now you can plug this in with this summation of x, y. It's a numerator. Okay? And how many are part of the sample? We have A to H, so that's 1, 2, 3, 4, 5, 6, 7, 8. That's 8 subjects or 8 provinces in total. So now, kompleto mo na si numerator. Now, to fill in the rest of the formula, we need to get x squared and y squared. So just go back to the original x and then square this. No, using your calculator, using your Excel. No, you can actually, there's a more straightforward way to do this. There's a correlation function in Excel, but I will need you to show me these tables in your process. So Excel could be a good bank checker, but what will matter for the course is you show me that you understand why Excel computed for you that correlation. Okay, so in the problem set, you will need to show this. So 10.4 squared is around 100 something. It's 108.16. So do the rest for the rest of the provinces and get the sum of this column, no, x squared, and you will get 1,139.25. Okay, so remember, you sum the column, no? You don't get the square of x, of sum of x. No, you will end up with the wrong values for your denominator. So now we have n, we now have sum of x squared and sum of x. Now y is on y squared na lang. So this one, 41.7 squared is 1,738.89. Okay, do the rest and then sum yung column of y squared. There, so it's 13,573.37. All right, now that you've completed the expanded data table, we can now go to the computations. No? So this is the formula for R, and we have the elements of the numerator and denominator with us, right? Because of the expanded data table. So let's just complete it. So it'll look something like this. No, this is your intermediate solution. All right. And you just do the computations. Okay. Until you arrive at this. So remember the square root. So you'll get around 0.980 as R, which is quite high. No, so remember that and refer to the table of interpretations table that I provided in the lecture notes. Now DF, we have 8 provinces in the sample. So that is 6 in DF, and then the coefficient of determination is simply R squared, so 0.980 squared. So you will get multiply it by 100, so you get 96.04%. So that's your computation, simple as that. So you just really need the elements from this expanded data table so that it'll be easier with the formula. Okay, now the elements table, this is what you will write here in the statistical analysis. It's Pearson correlation using Pearson's R. Now we still have the research hypothesis, the null and the alternative. Your null hypothesis should look something similar to this. The poverty rate in the province is not related to its teen pregnancy rate, and vice versa. If you want to be more specific, poverty rate is percentage, while the pregnancy rate you can actually convert into actual numbers of individuals, numbers of females aged 15 to 70. So yeah, but this is still acceptable, no? So as you can see, no relationship, so not related. Alternative hypothesis will argue otherwise that there is. All right. Now for the notation, it'll look something like this. Now P is equal to 0. No, and P is not equal to 0. Okay. Level of significance, it says test it at 0.05. Now, how do we find the critical value? We need the DF and your level of significance, which is 0.05. And we need to refer to the table of values. So let's look at that. So ito muna sa Pearson's R. All right. So here, remember our DF is 6 kasi 8 minus 2 is 6. So andito siya. And we will be dealing with two tails. No? The problem we won't specify na if it's a directional test. We'll just settle with the most simple, which is the simplest one, which is a two-tailed test. So 6, and then our significance level is 0.05, so that will be 0.7067. All right, so let's go back to the table. That should be positive and negative 0.7067. Now, as to the decision rule, ganito lang siya. If your R computed is greater than or equal to your R critical, then reject HO. So let's compare. 0.980, is it large, higher than 0.7067? Yes. Therefore, we reject HO. Now, this is what is crucial here. How do we interpret what we have just done as a whole? So we can say the data suggests that the poverty rate in the province is related to its teen pregnancy rate. It is most likely that significant, because we rejected the null. Strong, 0.98 yan, almost perfect. Positive, no? Because the sign is positive, no? Yung direction niya. Relationship exists between poverty rate in the province and the number of females aged 15 to 17 who gets pregnant, no, or who becomes pregnant for the females in the province gets pregnant from age 15 to 17. Uh, this means that as the province's poverty rate increases, so does the teenage pregnancy rate. Okay, and also vice versa. Now, to add more layers to our interpretation, we need to interpret the coefficient of determination, no? The variance. So as an explanatory variable or as a criterion, or as a predictor, sorry, teen, no, as a, is it a predictor? No, it's a criterion. Teenage pregnancy rate, this is supposed to be, what do you call this? Poverty rate can explain 96.04% of the difference in teen pregnancy rates in the selected provinces. So this is an error. This is supposed to be pregnancy rate. All right. So there. So that's your sample problem for correlation using Pearson's R. Now let's try on a sample problem on Spearman's rho, no, or Spearman's rank order coefficient. Now I think, I believe the sample problem that I've shared with you, which is this one, has some wrong elements, no? So I will rectify that by providing you with this new updated version that has correct elements or correct answers, no? So just bear with me as I do that. But for this one, we will try to do the sample problem, but with the correct answers. Okay, so disregard what I've sent you earlier for Spearman's rho. So here it is about a medical sociologist that wanted to find out the relationship between severity of illness, no, and the length of stay in the hospital, which is measured in days. So she ranked the seriousness of the elements, no, but what I did was I sort of invented these scores. Let's say the doctors of the patients were asked to complete a form, and we got hold of the scores on severity of illness. So in Spearman's rho, we need to, this interval data, and we need to transform it into rank order data or ordinal data. So we need to, basically rank the patients based on X and Y. So let's do that for X. No? So we start from the highest to the lowest. The highest will be placed as the first, no? And so on and so forth. So here in the severity of illness, the one who got the highest score is C. So they will be ranked 1 for Spearman's rho. Okay, followed by B. Oops, no, sorry. We still have, no, this is, C is 1, followed by 97, which is F. Right. And then we still have 90. This is the third placer. And dun pa lang si B. No? So if you ranked all of that, no, on your own, you will find na ganito yung magiging itsura ng ranks nila. No? C is first on the list, no, with the most severe or the most serious ailment, while the 8th place is D. 60 lang yung rating sa kanya ng severity of illness. So pang 8 siya. As you can see, no, there are no tied pairs here. No, each of them have unique scores on X, no, on severity of illness. So we don't have much of a problem there. Now for rank on Y, you will notice that 2 patients have the same length of stay in the hospital. No, patients E and F stayed in the hospital for 21 days. So that's a tied pair there. No? And I believe you've encountered this, yung breaking the tie, breaking tied pairs in school, right? When we were when you were being handed out recognition in the honors list, no, in the top 10 or top 15, mga ganyan, the teacher, the advisor usually breaks the tie by assigning um, a different rank for people who, let's say, had the same averages, no, semestral average or grading average. So that's the way to break the tie. Ganon din ang gagawin natin sa Spearman's Rule, no? So let's see. Si ENF, longest stay in the hospital, they should be ranked 1 pareho, no? But because they are a tied pair, we need to first get the sum of their scores and then divide it by 2 because there are 2 people involved. So 21 plus 21 is 42 divided by 2, right? Oops, sorry. I misunderstood that. So we just need to find out how many subjects are we trying to break their tie. So we have 2. Here, they are supposed to be ranked 1 and 2, right? So we need to divide that by 2 so that we will get their final rank, which is both 1.5 and 1.5. So essentially, they're sharing parang 3 spots, no? Rank 1, 2, and 3, 2 spots, rank 1 and 2. All right? So ganun din, you just need to find out how many subjects are we trying to break their tie or their pairs, and then divide it by the total number. Okay, so this is presumably rank 1 and 2. So 1 plus 2 divided by 2 because we have 2 subjects and you will get 1.5. So pag tatlo yan, si rank 1, 2, and 3 ang sinusubukan mong i-break, divided by 3, and you will get what is their supposed rank in this list, no? So ang susunod kay ENF is the one who stayed for 19 days, B. So siya ay magiging rank 3 na, no? So walang rank 2, only in rank 1, only 1.5 and 1.5. Then the rest will follow. No? Ang fourth placer natin is patient C na naka 18 days. Then 12 days si patient A. And then 10 days si patient H. And si G, patient G, stayed there for 5 days, which may rank them at 7. And last, only 3 days, which coincidentally also had the least serious illness or ailment. Rank 8 naman siya sa rank sa Y, or length of stay in the hospital. Now, what we have to do next is to get the difference between rank on X and rank on Y. So for A, that's 6 minus 5. No, but you need to square it, no, so that we plug it in here in the formula. So that 6 minus 5 is equal to 1 squared will give you 1. Do that for the rest, and you will get something like this. So why are we squaring it? We're trying to eliminate negative values, no? And get the sum of d squared, and you will get 14.5. Now you're ready to compute for Spearman's rule. So this is the formula. Ang mali dun sa una kong binigay na sample problem is I forgot to subtract this element from 1. So I ended up with a wrong answer. But yeah, we continue. So yun. So let's just put 1 minus here. and then 1 minus here. So yan we got 14.5 because ito yung sum of d squared. 6 is already a constant in the formula. So we just copied it. N is 8 because we have 8 patients in the sample. So yan. So, ituloy-tuloy natin siya and we will get something like this. So let me add 1 minus there. RS, the correlation coefficient for this problem is 0.827. Once again, that's quite high. That's a strong positive correlation once again. So, but first we need to compare it with RS critical, So we need to get the DF. DF is 8 minus 2 again, so that's 6. And then for R squared, we simply square yung Spearman's rank order coefficient that we obtained. So that's 0.827, it should give you 68.393. All right, let's go to the elements table. Here, so the statistical analysis used is Spearman's rho. And then the hypothesis, the null and alternative will look something like this. This is like a variation of our research hypothesis for Pearson's R earlier. There is no relationship between patient severity of illness and their length of stay in the hospital. Alternative, on the other hand, states that there is a relationship. So the statistical hypothesis will have to look something like this. So I just put PS and PS is equal to 0, not equal to 0. Level of significance, we're comfortable with 0.05. Now the critical value, you will need TF, which is 6, and your level of significance, 0.05. And instead of the Pearson's R table, we need the Spearman's rho table, this one. So let's use it to find our critical RS. So as you can see, it's a different table. This will, so yeah. If you notice, actually we computed for DF, as a matter of habit, but in the Spearman's rho table, we actually need to know N. So if our DF is 6, our N is actually 8. So refer to 8. 8. And then we chose 0.05. So we will use 0.738. All right. So let's go back to our example problem. So this should indicate 0.708. 0.738, sorry. So yeah, two-tailed ulit tayo. All right. The decision rule is similar to Pearson's R, that if the coefficient we computed is higher than the critical Spearman's rho value we found from the table, we reject HO. So it seems that we should be rejecting it. So the correct answer for this problem is this. Reject HO. It is most likely that there's a significant, moderately strong. Is that correct? Let's find out. So I checked. So it's not moderately strong. It is actually strong. So it's a significant, strong, positive relationship between patient's seriousness of their ailment and their length of stay in the hospital. Now we like explaining what the coefficient of determination is. We say that as an explanatory variable. The seriousness of a patient's ailment can explain about 68.393%, or R squared is equal to 0.684. of the differences in length of stay in the hospital, or of the variance or variation in the length of stay in the hospital. So yeah, that's how you conduct Spearman's Law. No? So the most challenging part here is ranking uh, the subjects or individuals based on their scores on X and Y. An added challenge is if certain subjects tie on a rank, no, but as I said, you just employ what our teachers, our advisors would do in case of ties for the honors list, no, or rankings in class. So there. So and then it's pretty much straightforward already. Okay. Now let's go to a sample problem for correlation using Goodman's and Kruskal's gamma. So the problem states a sociologist interested in the relationship between social class and amount of reading ask a sample of 105 children. Your N is 105 from varying socioeconomic backgrounds about the number of books they had read outside of school during the last year. So this is the table, no, that you will encounter in a problem like this. Now, how will it be an expanded data table? You simply need to get the sum for each column, the total columns, no? The column total, sorry. And ito yan. So for upper class, it's 23, upper middle class, 25, lower middle class, 26, lower class, 31. No? And that's it. You can move to the computations table. Now, the formula for gamma is this: NA minus NI over NA plus NI. NA refers to agreements. No? And when we say agreements, we are pertaining to um, how individuals are ranked in exactly the same order on both variables. All right. And inversions, yung NI refers to how individuals can be ranked in reverse order for both variables, meaning mataas sila sa X pero mababa sila sa Y. Unlike sa agreements naman na mataas sila sa X and mataas din sila sa Y. So parang ganon. Ganon yung whole point niya. And to get those NA and NI, no, so that it'll tell us more or less the direction of the correlation between X and Y. What we need to find is NA first. And we need to choose, we start with the upper left cell, no, which is 10 here, the example. And we need to find its product with the values that are below and to the right of 10, no, of this cell. So, ulitin ko, we will multiply 10 here, itong the upper left cell. We will multiply this to the values in other cells that are below, so nasa baba niya, but also to the right of it. So it needs to be below. So hindi kasama si 964. Possibly itong mga ito. But it also has to be to the right of this cell. So that will exclude 8 and 5. So in short, we need to get the product of 10 and the sum of these 6 cells. And that's basically your agreements. No? These are the cases that are below or to the right of this cell, which is what you call, these are your agreements, because as you can see here, no, these cases are both lower on both variables compared to this case. No, for upper class children, for children belonging to the upper class and have read more than one book in the last year, No, the cases that are below and to the right of them, meaning the cases that are both lower on socioeconomic class, upper middle, lower middle, or lower, and have read less than this case, ito yung kailangan nating kunin na sum. No? Now, I'd like to bring your attention to this. Notice how variable X classifications are arranged and variable Y classifications are arranged. Now, they are arranged in a decreasing order. Meaning, yung unang nakalagay dito is the highest in terms of classification or order, followed by the next highest, then the next, and the lowest. Ganon din dito. Ito presumes more than one book ang binasa. Ito isa lang, ito none. So you have to arrange your X and Y classifications in that order, in a decreasing order. So let's go back to NA, no, or number of agreements. So we need to get the product of this with the sum of all of this. So it should look something like this, right? So yeah, 10, this is 10 that we got from this, and then 10, 8, 12, 6, 12, 15, we got from this. And we simply multiplied it, this term with this one, and got 630. And we will do the rest for all the remaining cells. So we could go to the right next. We should go to the right next. So that's 9. So what are cases that are below it, but also to the right of it? Because those are the agreements for this particular case. Those are 8, 12, and 15, right? It helps to label, perhaps, no? Now, this time we're interested in the upper middle class children who have read more than one book in the last year. So that's 9 multiplied to 8 plus 12 plus 12 plus 15 equals 423. No? Then move to the next, yung lower middle naman. What is or what are cases that are below it but also to its right? And that's 12 and 15. So you will end up with this. Then 4, meron bang below sa kanya, sa lower D, lower class? Yes, merong below it, which are 12 and 15, but are there cases to the right of it? To the right of 4? None. So we don't have an agreement or agreements for that. So we proceed with, we go back here, sa upper class that have read one book. So that's 8. Cases that are below and to the right of it are 6, 12, and 15. So we need to get the sum of that and multiply it to 8. So yeah, 264. Then tuloy-tuloy lang natin. Next is upper middle class which have read one book. Cases below and to the right of it are 12 and 15. All right. And then I think the last case that we are interested in is 8. Yung lower middle classes have read at least one book. And technically, isa lang yung case that are in agreement with that case. Ito, yung 15. Lower, children from the lower class who have read no books at all in the last year. So we put it here. Yeah. So do we have any other agreements that we need to settle? Wala na, because for this last classification on Y, wala nang scores. There are no other cases that are below it and more so to the right of it. So we can actually get NA already, no? And we get NA by adding together all these agreements. And there. So our NA is actually 1869. All right. Now, NI naman follows a similar logic, except that inversions refer to all individuals that are ranked in exactly the reverse order on both variables, meaning they are high on X but are low on Y, or they're high on Y but low on X. Now, for this one, we start with the upper right case or panel, which is 4. No, children who belong to the lower class in terms of socioeconomic status but have read more than one book. Now we need to find cases that are below it, but now to the left of such case. No? So kung 4 yan, we are pertaining to these cases right here. All right. So let's see. So it would look something like that. You get the product of 4 with these cases because those are your inversions. I get 196. Then tuloy-tuloy lang yung process. No, from 4, you move on to 6, find its inversions, then move to this panel and find its inversions, which are 8 and 5. Then obviously this one will not have any inversions. So go down, start with 12, find its inversions, ito. Then go to 8, find its inversions and get their product. Find 10 and get its inversion. Find their product. And yeah, simply add the inversions. No? And so you will end up with something like this. And Ni is their sum. Yan. All right. With that, you now have the elements of the formula. So you just have to plug it in and remember the signs for the numerator and denominator. So yeah, you get 0.349 as your gamma coefficient, which is quite low, right? It's not unlike for the Spearman and Pearsons na nasa 0.9 and 0.8, ito 0.349 lang. Now, to test the significance of this, you need to get a z-score for gamma. And basically, you just use whatever you have gotten from what is your Na, what is your Ni and G, and plug it in this formula. And you'll end up with an answer. Here. All right. Yeah. So 0.349 yung G. Na is 1869 added to Ni, which is 901. No? N is 105, if you recall, here. And that's 1.1913. So we will use that value later to compare it with G. All right. And R squared has the same idea as previous sample problems. So see, 0.349 squared is 12.180%. That is your coefficient of determination. Now the elements table is here. So ito, we used gamma. And then the research hypothesis will look something like this. A relationship does not exist between children's social class and their amount of reading outside of school during the last year. Alternative goes like, a relationship exists between social class of children and the amount of reading they have done outside of school during the last year. For statistical notation, ito siya. It's Y. This is gamma, by the way. This is the sign for gamma. Gamma is equal to 0. Gamma is not equal to 0. Then we use 0.05. And then now the critical value is what we solved for. It's 1.913. So we just simply write it down here. no tables whatsoever, right? So the decision rule is similar, no? If the z-score we computed 1.91, if the z-score we gamma is greater than the z-critical 1.913, then reject HO. In this case, we are retaining HO, no? Because 0.349 is lower than 1.913. No? And this means that a relationship does not exist between children's social class and their amount of reading outside of school during the last year. As an explanatory variable, social class X can explain only 12.18% of the differences in the number of books read by the children outside of school in the last year. No, we no longer interpreted the relationship. No, this is interpretable, right? This is 0.349 is around. Let me check. 0.34. It's a moderate positive correlation, but don't bother interpreting it because it's not a significant relationship. No, but in others, like in your actual thesis or research, you might need to interpret it still. But for us, wag na lang. No, but in actual research, you might still need, no, and that's when you try to explain or try to theorize why you didn't get a significant result and why, for instance, your coefficient of determination yielded a very low percentage. It's just 12.180. So aside from social class, no, what else could explain the differences in the number of books read by the children outside of school during the last year? No, kasi social class, I would have assumed explained a lot, no, in terms of access, in terms of access to resources such as books, no, perhaps even the context where these children lived, no, there I would assume uh, an upper social class would have not just access but would have more systems in place to encourage children to read. So perhaps there'll be setting up more facilities for reading, libraries, mga ganyan. So what else besides social, dito na pumapasok yung social science of it all. What else besides social class could potentially explain the number of books read by the children outside of school in the last year? No, if it's not social class, what else? Could it be gender? No, could it be the number of parents that are taking care of the child? So mga ganon. So there, that's your gamma example sample problem. Now let's move on to the last sample problem for correlation. Now using phi coefficient. In the table below are the responses of a sample of male and female students to a question on an attitude scale. Is there a correlation between gender and given response? So this is quite a simplified problem. So it just states that the hypothetical researcher collected data on male and female respondents, asked them a question on an attitude scale that solicits an answer of either an agree or disagree. And they simply cross-tabulated the data. No? This is clearly a frequency count. No? 2 by 2 pa siya. So there are females who agreed that there are 100 females who agreed to the question, or their answer is agree to the question, and there are 80 who disagree. Meron namang males 60 and 120 males who disagree. to that question on the attitude scale. Now, how do we expand the data table or the contingency table for phi coefficient? We simply get the row totals and the column totals. No? So we will end up with this 100 plus, oops, I once again found an error. So the row total for females is 180 because 100 plus 80 is 180. For the males, it's also 180. All right. For column total, for agree, it's 160. And for disagree, it's 200. No? So let me mark that as an error that I need to correct once I give this out to you. All right. So as I was saying, I detected some errors in the previous, certain elements in this sample problem. So I trying to correct it now, then I'll send this to you once I'm done demonstrating it. So for instance, ito, the grand total is actually 360. Then if we get the formula, AD minus BC over square root of KLMNN, merong iba dito na mag-iiba because mali yung gamit kong row totals earlier. But you will have to end up with a phi coefficient of 0.224. So that's a very weak correlation. No, it's a positive weak correlation. Then find out what is your TF. It's R minus 1 times C minus 1. You'll end up with 1. No? Because R refers to rows. There are 2 rows here with scores. And the columns are 2 as well. 2 columns with scores. 1, 2. 1, 2 rows. Now let's solve for the critical phi coefficient. Phi's critical value for phi. So yeah. So how did we get x2 critical? We need to refer to the chi-square table. No? So let's go to that. Bakit 3.841 ito? Here. So this is your chi-square distribution table. The degrees of freedom we got is 1, and we are settling with 0.05 as alpha level, so it's 3.841. All right, so let's go back. So denominator is 360. No? And you get the square root of that, and you get 0.1, 0.03. So that's your critical value that you will compare against the phi coefficient that you calculated. But first, let's get R squared. No? Using 0.224 squared, that's 5.018% of the total. That's how much X, which is your gender or sex, could explain the variance or the variations in the responses that were given in the question. So that's quite low actually. So the researcher here might need to look for other predictors, other correlates of the answer. Baka hindi sex or gender yung talagang could really help explain why the respondents answered that way. It could be age, education status, socioeconomic status, if they live in rural or urban, so mga ganun. So for the elements table, this is using phi, and the research hypothesis is, so there is no relationship between students' gender and their response on a question on an attitude scale. So I'd like to comment. I think you've heard me either flip-flop on the gender and sex thing. We know that's different based on SOGI. But many researchers are still confused about it. I would say because this particular example used only male and female, um, I would say gender is sort of a problematic variable, term for the variable to use, because obviously we know there are different genders aside from male and female, these binary classifications. So, and that's one thing that we can correct already, no? That this problem might have been pertaining to sex assigned birth, I think, which is more politically correct, given that we only have two categories for this. So I would much rather, I think I'm more comfortable using sex assigned at birth. So there, because gender has other, we want to recognize other queer identities. So yeah, I would like to correct that. So yeah, there is no, for HO, there's no relationship between student sex assigned at birth and the response on a question on an attitude scale. Alternative is there is a relationship, no? The notation, mag-iiba lang ng konti, we are using the phi symbol. So P is equal to 0 and P is not equal to 0. So nagamit na natin yung 0.05. Yung critical value, nahanap na rin natin si phi critical, which is 0.103. The decision rule is straightforward. If the phi computed is greater than or equal to the phi critical, then reject HO. In this case, it is, so we reject HO, right? It is most likely that a significant, weak, but positive relationship exists between students' sex assigned at birth and their response on question on an attitude scale. So let me just make that red so that you'll notice a difference when you check out this new thing that I'll load this revision. And as an explanatory variable, students sex assigned at birth can only explain 5.018% of the differences in their response to a question on an attitude scale. All right, so that's it. That's your sample problem for correlation using phi coefficient. So in this video alone, we went through 4. No one using the Pearson's R, another using Spearman's rho, another one using gamma by Goodman and Kruskal, and last one is the phi coefficient. I hope you noticed that more or less they have very straightforward procedures. Others are more tedious than the rest and a little bit challenging, but I think it's really manageable naman. And especially with Pearson's, you can actually do this in Excel or in other softwares. So I just want to remind that, yes, you can check, verify if your answers are correct using Excel, but I would prefer, and you will need to show to me the step-by-step process when submitting the requirements. Okay? So there. Thank you for listening and watching to this demo video. Next time, we will end the course with regression analysis and a sample problem on that topic as well. Thank you so much.